Question 17, and by the looks of it, it's a titration question. So I need to work out how much of this stuff is in my extract. So what I need to find out is this stuff here. So therefore, I know I'm going to work out that from my titration, because in a titration, you're reacting your two reactants together. So what's my titer? My titer is that, so therefore my number of moles of MnO4 negative equals C times V, which is 0.021 times concentration of my permanganate, 0.02. Get my calculator up. That is going to be 0.021 times 0.02. Gives me that number there, which is 4.2 times 10 to the power of negative 4. My ratio here is a bit of a whack one. It's 2 to 5, so I need to work out that. So I'm going to divide that by where I came from and times it by where I'm going. So divide by 2 times by 5 to get my ratio happening. So therefore my number of moles of my, I think it's oxalate, is it? Oxalic acid. Yeah, so my oxalate ion is going to be 1.05 times 10 to the power of negative 3. That's mole. This is in concentration, so it's molar. So concentration of C2O42 negative equals N over V. What was my concentration? What was my aliquot of rhubarb stuff? It was 20 mil. So I'm going to do that times 10 to the power of negative 3 divided by 0.02. So I'm going to take that number again, divide it by 0.02, and I end up with 0.0525. So therefore, that is 12. So it is going to be 5.25 times 10 to the power of negative 2, which my closest answer is this guy here by the looks of it. It's not exactly that, but anyway, I'm going to move on. I'm going to say it's B. Let's move on. Question 18. What do I need to rinse things with? All right, so which of the following rinses is least likely to affect the accuracy of the results? So what do I need to rinse it with? So my item, my burette, should be rinsed with what goes in it. So distilled water is not right. I'm guessing my titration was with, my titration was with KNO4. My burette was filled with that, so it should be rinsed with that. So burette should not be rinsed with rhubarb extract because my burette should be KMNO4. My pipette is where I took my aliquot from, and that should be rhubarb extract, so it's not that. My conical flask should be with distilled water. That is correct because your conical flask, okay, what you're doing is that's not measuring anything. So if you're not measuring anything, rinse it with distilled water. If you're measuring something in it, rinse with what goes in it. Next one, which of the following molecules contain a chiral carbon? Chiral carbons again. All right, chiral carbons, 4 different things attached to the one carbon. So let's look at these. That's not a chiral carbon. That's a double bond. In here, we've got CH2, double bond to CH to C. So that's what that is. So it's not going to be that. It's not going to be that one. This guy here is looking... No, we've got 2 hydrogens, 2 hydrogens, 2 hydrogens. Not going to be right because you can't have 4 different things if you've got 2 hydrogens on it. Not possible. This carbon here is looking promising. I'll look at this one. CH3, not chiral, but then I've got CH and then to H, then CH2, CH3. This guy here is chiral. So it's going to be C. Answer is going to be C there. Why is this one not right? Let's have a look at this. Let's draw it out. Helps to draw out structures sometimes. It's 1, 2, 3, 4, 5 carbons. F and Cl. Whilst it looks like it's going to be chiral, we've got symmetry here. So this carbon is exactly the same as this carbon, so it's not right. So this could be written as this. And it should be CH2 and C2H5. So therefore, that is not chiral. So it's going to be C as our answer. Question 20, and we're looking like we're doing some temperature stuff here because this looks like a Maxwell-Boltzmann distribution. Question is, which of the following statements indicates the change from graph 1 to graph 2. So what are we going? I'm going from this graph into this graph. So graph 1 is a high temperature. You should recognize it as being a high temperature. It's got more energy. And graph 2 has a low temperature because more particles have less energy. So that should be your understanding of a Maxwell-Boltzmann distribution. The average kinetic energy of gas molecules has decreased. From graph 1 to graph 2, the average kinetic energy, that's true because we've lowered our temperature. More gas at the same temperature was added. That's not right because all we're doing is change our temperature. More collisions occurred. That's not right because we've lowered our temperature. The gas was increased. The temperature of the gas was increased. That's not right. Answer is definitely A there because we can clearly see that from graph 1 to graph 2, it's lowering temperature. Got to be careful with this question because they've put graph 2 as our first written one from left to right, so it could be confusing. Question 21. Use a physical property to distinguish between two alcohols. So we're looking between a long chain alcohol and a short chain alcohol by the looks of it. So what should we expect between these two? Solubility is my first go-to because we've got difference in length of chains, and viscosity could be different as well. Density, I'm not going to talk about that. I just don't think it's right. Boiling point, because octanol has a higher boiling point than propanol. That would be true because we've got a longer chain of carbons. Therefore, your boiling point is going to be different. And a longer chain will have a higher boiling point because you've got more dispersion forces happening with it. Electrical conductivity, no, they're both not going to conduct electricity. Spectroscopy, because it's not just possible to distinguish between alcohols using their physical property. Not true. It's going to be B. This is a classic idea. If you had a mixture of these two, you should do some distillation and you'll get the propanol distilling out first and the octanol coming out afterwards because it's got a higher boiling point. So we'll move on. Boiling point's definitely the one for question 21. Question 22. 4 fuels undergo complete combustion. So complete combustion, we're forming CO2. Used to that. Assuming there was no energy loss to the environment, which of these fuels will increase the temperature from water from that to that? So we're looking for which one of these is going to produce a particular amount of energy. Let's have a look. We're being 1,000 grams of water. So our energy equals specific capacity times mass times delta T, or Q equals MC delta T. So therefore 1,000 times 4.1 times our temperature change here, which is 60. So which one of these is going to produce this much energy? 1,000 times 4.18 times 60. There's probably a simpler way of doing this, but I'm going to go with this. 25,800 joules, which is 250.8 kilojoules. So I need my data booklet for this. So I'm going to pause this and find a data booklet. So here's my data booklet. Let's have a look for the energy content part. So it's not there. It is here. So what we need to do is work out how can we get 250 kilojoules. So I do for my hydrogen, I've got grams, so 0.889 times by kilojoules per gram here of hydrogen. Well, that's not going to be it because it's going to be less than 1 times that. So it's certainly not going to be the hydrogen part. 3.95 grams of propane. So 3.95 times propane, 50.5, gives me 199. So it's not that one. 0.2 mole of methane. So 0.282 times my methane mole, which is 890. That's looking pretty good. All right, because that number there is the same as my number that I worked out here. Well, pretty much. Just double checking that this one's not closer, which I highly doubt it very much, which is 0.301 times by methanol's mole value, 726, gives me, yeah, it's not it there. So the key thing is here, work out how much energy you require and then use your data booklet correctly, just being careful to see that some of these were in grams and some of them were in mole. Question 23. Student based on this information, the student recommend petro-diesel rather than biodiesel. So we need to understand the difference between petro-diesel and biodiesel. Petro-diesel is more hygroscopic. No, okay, that's not true because it doesn't attract water. That means that one's not true because it doesn't attract water. It's less hygroscopic, it's more viscous. That's not true. Petro-diesel is less viscous. So therefore, D makes the most sense here because even if I didn't read this, I know the properties of petro-diesel and biodiesel. Question 24. We got some equilibrium systems here. We got delta H's. After equilibrium was established in each system, the temperature was decreased and the pressure was increased. Which of these would result in an increased yield? So increased yield, we want to favour the forward reaction. If we decrease temperature, that's going to favour the exothermic reaction. So it's either going to be this one or this one. Okay. If you increase the pressure, that's going to favour the side with less particles. So therefore, I have a look on here. We've got 3 particles on this side, 2 on that side. So that means it's going to favour the forward reaction. This one has equal number of particles on both sides, so therefore increased pressure is not going to do anything for yield. What that suggests, it's going to be equation 1. Moving on. Question 25. The molar heat of combustion for pentanol is this. If you've got a molar mass of pentanol of this, the mass in tons required to produce this much energy is what? So the molar mass is that. So what we want to do is we want to divide this by, I can convert that into 3.329 megajoules per mole, because this is in megajoules. Divide that by 3.329, gives me what? 3.329, 10800 divided by my 3.329 gives me 3,244 mole. I'll times that by my molar mass, which is 88 there. So that's going to give me 2,85491 grams. Divide that by 1,000, gives me into kilograms. Divide that by 1,000 again, will get me into tons. So that's going to be B. Because this is grams, divide by 1,000 gives me kilograms, and divide by 1,000 gives me tons. And that's how I like to work out my conversions in masses. Particularly when we're going above kilograms, I don't like to think about divide by a million. I kind of like to go with the 1,000 based units. So that's question 25.